So justifying the steps in solving one variable inequalities. Just like in section 2.6, where we justified the steps in solving equations, we can justify the steps in solving inequalities. We need to specify what properties we're going to be allowed to use. We're using the addition-subtraction property of inequality, which I will abbreviate as a plus sign with a circle property of inequality. Remember that subtraction is addition, but just with negative signs, so I'm just going to always write it as a plus, because I can add a negative or I can add a positive. And then I have two multiplication/division property of inequality. You'll remember in the notes we took in solving inequality, one variable inequalities, we discovered that when I divide by a number that's negative, less than 0, I need to flip my inequality. And so that's why we have two. We have a case where the number I'm multiplying or dividing is positive and one where it's negative. And again, multiplication, division are the same operation. Division is just multiplication of a reciprocal. So I always use just the multiplication symbol with a circle and then P of or POI, and then specifying is the number I'm multiplying greater than 0 or less than 0. So now let's look at a couple of examples. Example 1. Solve and justify your steps. And we're going to look at the equation 3x minus 8 is greater than 10. So very often when I do this, it's nice to have sort of a two-column. So I start with 3x minus 8 is greater than 10. And then I draw a line. And then I have a column to be writing down my steps in. So as we get more sophisticated in solving equations, we stop writing down the steps that I've been writing in a separate color ink. So all this time we've been writing down plus 8 and plus 8. But once we get more sophisticated in our math, we'll actually not write the plus 8 and plus 8, and we'll just go straight to 3x is greater than 18. The property that I'm going to write here, I'm only going to write properties for the blue portion of what I'm writing, is what I did. And what I did was I added something to both sides of the inequality. So we have addition property of inequality. My next step in solving this equation is to divide both sides by 3. Again, what I'm writing in red are sort of my notes to self. And so I'm not going to list a property for that. The property is the process of going from this line to this line. And what I did going from this line to this line was divided by 3. Now remember, dividing is the same as multiplying. If I'm dividing by 3, that's the same as multiplying by 1/3. So I have multiplication property of inequality. In this example, our a, the number we're dividing by, is positive. So I say, hey, look, a is greater than 0. Example 2. Solve and justify your steps to the equation negative 1/2 x plus 7 is less than or equal to 4. Again, I'm going to do this setting it up with two columns. And again, I'm going to use my red to sort of show my thinking, but it's not actually the step. That's not what I'm going to write my justification for. So the first step, I'm going to subtract 7 on both sides. That gets me negative 1/2 x less than or equal to negative 3. Here I subtracted 7 on both sides. But remember, subtracting is the same as adding a negative. So it's still addition, property of inequality. Remember, in 2.6, we talked about property of equality, but we don't have an equality, an equal sign. We have an inequality, an inequality. Now, we actually talked in a previous section how we don't necessarily want to divide both sides by -1/2, but it would be really great to multiply both sides by the reciprocal of -1/2. When I do that, my reciprocal of -1/2 and 1/2 cancel, and I'm left with x. Now, I have to remember, though, at this point that I am multiplying by a negative. So that means I have to flip my inequality. And then I simplify -3 times -2. So this time, I still have the multiplication of inequality, just like we saw in example 1, but I have to say that my a, what I am multiplying or dividing both sides by, is negative, less than 0.